Section 8.2 is about polar equations and their graphs. So today we're going to identify and graph polar equations by converting to rectangular equations. We are not going to be learning to test polar equations for symmetry. I'm sorry. We've only really got one objective. Identify and graph polar equations by converting to a rectangular equation. So in the last video, I introduced the difference between rectangular coordinates and polar coordinates. So an equation whose variables are polar coordinates is called a polar equation. And the graph of a polar equation consists of all points whose polar coordinates satisfy the equation, right? That's the definition of equation. If I have the graph of a line, the solution, the graph, is every single point that makes the equation of that line a true statement. So here are some examples of polar equations. We're primarily going to be working with circles, as we don't have time to go more deeply into cardioids and one-loop limicons and inner-loop limicon, but these are some different shapes that you can get using polar coordinates. Cardioid is called that because it looks kind of like a heart. Think of like cardiovascular, right, like a heart shape. Another shape that can form is this shape here, and you might be like, oh, that's the infinity symbol. No, actually, that's a limb skate, and it's a pretty cool shape. So let's keep in mind that the graphs of a polar coordinate is all points whose polar coordinates satisfy the equation. So let's take a look at our first example. So we're going to identify, graph polar equations by converting to rectangular equations. So let's identify and graph the equation r equals 4. So if I have a point when r is 4, it doesn't matter what theta isn't defined. Where does r equal 4? Well, r equals 4 here, and over here, and here, right? It's going to be every single point where the radius from my pole, the origin, is 4. So this graph is going to look like a circle. So how do I convert r equals 4 to rectangular coordinates? Well, let's go ahead and square both sides. R squared is 16. R squared is x squared plus y squared, so I have x squared plus y squared equals 16. So if I have r equals something, right, r being our radius, when I have r equals something, I'm going to get a circle. Next, what if I have theta equals 3 pi over 4? Well, here's where all the points that are 3 pi over 4, right, but also down here, so we have, oh, I didn't draw a straight line. Let me fix that. So we have our graph is a line. Let me show you how we could figure that out. So if I have tan of 3 pi over 4, that's going to be the tangent of when x is negative square root of 2 over 2 and y is square root of 2 over 2. Well, that means the tangent of 3 pi over 4, which is y over x, is negative 1. So I have y over x equals negative 1. Solving for y, I get y equals negative x, right? That looks like something in slope-intercept form, right? My slope-intercept in this case is 0. Now, what if I have r sine of theta equals 3? Remember, r sine of theta is y. So this is the equation y equals 3. Well, the graph of y equals 3 is a horizontal line. Next, if I have r cosine theta is negative 4, well, the graph of r cosine theta is x. So I have x equals negative 4. This graph is going to look like a vertical line. So here's our theorem that discusses the graphs of horizontal and vertical lines. It is Theorem 1 in Section 8.1. If you want to take a look at that, feel free to pause. So earlier in example 1, I said when r equals something, our graph is going to be a circle. So to transform this equation from rectangular coordinates, We're going to multiply each side by r, right? That's a trick we've been using since this first section. So I have r equals 2 sine of theta. That means r squared is 2 r sine theta. R sine theta is y. R squared is x squared plus y squared. Remember, we're using our toolbox. These are the 3 tools in our toolbox. That's it. These are all the tools we need, and maybe a unit circle. Now I'm going to go ahead and solve for this circle so I can graph it. I need to find its center, and I need to find its radius. Remember that the general form of the circle is x minus h squared plus y minus k squared is r squared, where r is our radius and hk is our center, and that's going to help us graph this circle. So I have x squared plus y squared minus 2y equals 0, and I'm going to use the method of completing the square. So I add negative 2 divided by 2 squared to both sides, which is 1. So I have x squared plus y minus 1 squared is 1. That means my center is when x is 0 and y is 1, and my radius is the square root of 1, which is 1. So here's when x is 0 and y is 1, and my circle's radius is 1. Okay, I tried my best. Let's do one more example. We're finding a circle. Remember, if I get r equals to something, its graph is going to look like a circle. So if I have r equals negative 4 cosine theta, that means r squared equals negative 4 r cosine theta. We used our trick of multiplying both sides by r. R squared is x squared plus y squared. R cosine theta is x. I have x squared plus 4x, so I'm moving it over, plus y squared equals 0. And I add 4 over 2 squared to both sides. Well, 4 divided by 2 squared is 4. So I have x plus 2 squared plus y squared. So my center, because this is supposed to be negative, it's x minus a negative 2. My center is when x is negative 2, y is 0. And my radius is the square root of 4, which is 2. So when x is negative 2, y is 0. And then my radius is 2. If I make this circle too big, I did. Here's negative 2. We can go ahead and draw our circle as best as we can. So there we have our circle with center, x is negative 2, y is 0, and a radius of 2. This is its new equation in rectangular coordinates, and here it was in polar form.